And underneath them we've got some playing cards and a roll of sellotape. And the playing cards and the roll of sellotape are there just to stop making too much noise, and the magnets collapse away from each other or just fall down.
Yeah, and because the magnets don't contain any energy whatsoever, if you're a complete freakhead, they are a figment of your imagination and are not holding themselves to the piece of metal at all. I am doing it telepathically, telekinetically, and it's just a figment of your imagination and an illusion.
Now, as you can see, there's lots of stuff.
Yeah, so as you can see, they rock side to side when I touch them.
Different magnets here, and they're hanging off a metal thing. They're a pretty sturdy construction, as you can see. They've got plenty of self-force. They don't like coming to bits.
Yeah, they're that sturdy that it could be said that they've got an internal energy force.
You can take them off and lift them back up again.
And of course, apart from demonstrating magnetic energies, taking them off and then putting them back up again, and taking them off and putting them back up again, and then taking them off and putting them back up again, is extremely great fun.
See, they're a pretty strong set of magnets. So what I surmise is, you see straight in the centre there, where you look straight through now, there's a focal point holding them all together.
Yeah, and the focal point in the centre there is a focal point. And if the scientists that don't believe that magnets contain energies had a focal point, someplace where they all agreed, then maybe I would believe what they've written. But because they're all a complete bunch of... Ooh, calm down, I'm getting a little excited now, because I'm so angry about these idiots going on my website and trying to tell me that magnets haven't got any energy inside them. Well, prove it, mate. I've just proved that these magnets, right? I stick them onto that piece of metal, and then I'll leave them there. Now you could say that, oh, I lifted them onto that piece of metal, and that's defying gravity, right? But as soon as I let go of them, and they're not falling to the ground, then there's some energy holding them off of gravity, and it's not me anymore. Do you understand? Right? And then you could say that the magnet at the top, of which is around about how many? Go and count them. Right? The magnet at the top is definitely stuck to the metal that I've stuck it to. It's definitely clinging to it. Right? But the magnet at the bottom hasn't got a cat's chance in hell of clinging to that metal at that kind of distance. It hasn't got that kind of attraction. In fact, if I took all of the rest of those magnets away and just left that magnet at the bottom, that big cup magnet at the bottom there, left it where it was, it would more than likely travel across the table and cling to the shaft that's within the clamp. Right? Because it's got energies.
And they're opposite to each other. And what you actually got is, at the top there, it's clinging onto the metal stabiliser because it's magnetic, because metal's magnetic, it's attracted to magnetism.
Yeah, it's the magnetic energies that it's attracted to. Yeah, or should I say, the magnetic energies in the magnet attract metals. Or should I say attract ferrous metals? Oh, yeah, that's it. It's a magnetic ferrous. Oh, ferromagnetic stuff. That was the one.
And then the magnets are clearly off the floor there, as you can see. They're clearly off the floor there. They're being sustained together, like that.